this video, I'm going to show you how to make a small homemade hobby forge. The forge is made out of a number 10 can, commonly referred to as a coffee can, and some nuts and bolts. I plot out where I'm going to drill the holes for the legs on the can. Here you can see I've drilled the holes and installed the legs. I plot a mark where the burner will enter the casing. I center punch the mark and then drill. A larger step bit is used to finalize the diameter. Quick test fit of the burner, looks good. With this odd pipe you could see how the burner is going to enter the forge. This is perlite. It's a very interesting material. It's an expanded rock. It has a consistency of styrofoam. It's very insulating. Here I'm mixing in sodium silicate that I made in an earlier video. To the sodium silicate I'm adding a small amount of plaster of Paris. The plaster of Paris serves as an accelerator by competing for the excess moisture. It will set up quicker. Here I've added the perlite and I mix until I get a consistency of wet sand. Then you just plop it into the bottom. Here you can see it all rammed down into the bottom. I prepare another batch for the walls. With the center form and the burner form in place, I ram up the sides of the forge. Each layer is a small batch because with the addition of the plaster, this stuff sets up fairly quickly. One more batch brings the refractory lining all the way up to the top. But it's not a forge without a burner. Here you see a stainless steel tube with a stainless steel strainer at the end of it. That piece of strainer was cut from a sink drain strainer cup similar to this one. I also have a 3/8 by 2 inch brass pipe. A threaded ring to hold the brass pipe centered in the stainless steel one. As well as a 3/8 to 1/8 coupler with my primary combustion air holes drilled into the side. Essentially the same as my propane camp stove. This assembly then slides into the stainless steel tube. However, I plan on updating this design slightly here in just a moment. Here you can see the orifice, which is a 1/8 NPT plug with a hole drilled in it, a 1/8 coupler, and a 1/8 hose barb. It simply screws onto the back of this assembly. The stainless steel tube is actually this Apple coring tool I got for about $4. After cutting off this plastic piece, you're left with a nice large stainless steel tube. And I'm going to be using this entire length. Here it is assembled with the longer, newer tube, and it burns much better. Light it up. The refractory lining has been drying for a day or two. As you can see, the forge heats up very fast. And the sodium silicate is binding the perlite particles together nicely. Despite the intense heat, the outside is still cool to the touch. This forge can be used the way it is, however, I chose to seal the perlite with a special cement that I'm going to make now. This is sodium silicate, aluminum oxide sandblasting abrasive, and magnesium silicate, also known as baby powder. Into a disposable container, the sodium silicate is added. I'm not measuring anything, I'm just kind of going by consistency. To the sodium silicate, I add the magnesium silicate. I tried to find unscented talcum powder, but couldn't, so this reeks like baby powder. This mixture of magnesium silicate and sodium silicate has been used for temporary automotive exhaust repairs. However, I'm going to be bulking this mix up with a highly temperature resistant material. This is aluminum oxide. A very small amount of plaster of Paris is added to this mix to help speed up the curing time. Now that my high temperature cement is mixed, I simply spread it onto the surface of the refractory lining. It's about the consistency of cake frosting in a similar process. Now that the inside is completely coated, I'm going to seal off the top, or what would be the front of the forge. Smooth it all off and wait a couple days for this to cure. In the meantime, I've got some other high temperature projects in the works, so be sure to stay tuned for those.